Hello student, to the Foundation of Classical Electrodynamics course. So, under module 2, today we have lecture number 35, where we will going to discuss about the monopole and dipole moment. So, today we have class number 35. So, let us remind what we have done in the last class. So, if we have a distribution of the charge and take a small element here from that distribution with some origin, and this point was say r prime, and we had another point r, and try to find out the potential at that point. So, this point was P. So, try to find out the potential at this point P, and the charge distribution here is defined by this charge density rho, which is a function of r prime. And when we elaborate that, this was our, we find that our potential at the point r was simply comes out to be the summation of the contribution of the monopole, contribution of the dipole, potential due to the dipole, potential due to the quadrupole. We will discuss this again, and so on, where this phi 1, as I mentioned, is simply 1 divided by 4 pi epsilon 0, then integration of rho r prime, and then dv prime divided by r. This is potential due to the monopole. Now, similarly, we can write the potential phi 2, the contribution due to the potential, the contribution due to the dipole term, and this term was this, and then 1 divided by r square, let us put this r outside, integration, then r, and then rho unit vector r, not unit vector r, there is a cos term. So, let me write down that first. It was r then cos theta prime and rho r prime dv prime. Now, r prime cos theta prime, we wrote it unit vector r dot r prime, that leads to phi 2 as, that leads to phi 2 as 1 divided by 4 pi epsilon naught, and then I can write P dot r divided by r square, where P was the dipole moment defined as integration r rho r prime and dV prime over this volume. So, that was the dipole moment term. Okay. So, that was last day's work. So, last day's task. So, now today we will going to elaborate the concept of dipole and try to by using few examples, important examples. So, normally we know the dipole is generally defined as two equal and opposite charge with a separation say d, and the dipole moment. What is the dipole moment? The dipole moment is P is equal to Q multiplied by d. That is the very standard result, and normally that is the way when you are school the dipole was introduced. Now, I also mentioned that dipole can also be considered with the fact that this a system of charge having total charge 0, but this quantity which is written here, this integration r dot rho dV, this is non-zero, then that can also be considered as a dipole. So, in that case it is not necessarily that two charges will be there will be more charges, and still we can find out the dipole. One example is, suppose we have a charge distribution, this is also a discrete charge distribution like this. So, one charge is minus q, and this is say q, and this is another q. So, this is a system where the charge are distributed like this, where all these are A. Now, if the question is asked that what is the dipole moment, what is the dipole moment of this system, then the answer will not be that simple, because it depends on the origin. So, we need to ask that under, with respect to what origin, that is the question one can ask. What with respect to say with respect to what origin. Later we will see a very important thing, that when the total charge is 0, the dipole moment does not depend on the value of the dipole moment, does not depend on the coordinate system. But if the dipole if the total charge is non-zero, for here the q total charge q is non-zero, right? I have plus q, minus q and plus q. So, that gives me a total plus q. So, which is not equal to 0. In that case, in that kind of distribution, if you want to find out the dipole moment, it depends on the coordinate system. So, this is independent of the coordinate system, because here the total q total was 0. So, independent of the coordinate system, but this is not. We are going to prove that. So, let us do one problem, and after having the idea about the dipole, that it does not contain only the two charge, but its system of charge. The thing is that you need to calculate this quantity and check what should be the dipole moment. And another important thing that we understand here, that if the total charge is not equal to 0, for example, here we have 3 charges, that means the total charge is not equal to 0, and then the question is asked that what should be the dipole moment, the answer is not very straightforward. because in that case you need to know that with respect to what origin I need to calculate that, because it depends on the coordinate system. Now it depends on the coordinate system because the total charge is non-zero. Well, let us do one problem, then it may be the concept with this problem, maybe the concept will be clear. So, problem 1. So, I can have a coordinate system like this. This is the coordinate system that is given, and 3 distribution of the charge is there. So, then first case 1, I have a charge sitting in the origin and another charge sitting here, and the distance between these two charges is a, but the charge which is at the origin is minus q and the charge that is here is plus 3q. Again you can see that the total charge is non-zero. So, that means if you calculate the dipole moment, so definitely the coordinate come into the picture. So, this is case 1. Case 2, I have another similar kind of coordinate system. Okay, let me define the coordinates. Say this is x axis, this is y axis and this is z axis. So, this is x, this is y and this is z. In the next case, the charge particle, the two charges are sitting like this. So, I have one charge here and another charge say here. This is 3q plus 3q and this is minus q, and this length from here to here is a, like before. Okay. So, and finally, I have another distribution. Distribution 3. Let me first draw that coordinate. This is x, this is y and this is z, and the charge now is distributed like here one charge and over x axis I have another charge. So, this charge is minus q and this is plus 3q. As usual, the distance between these two is a. Okay, so, these are the 3 system that is given to us, and the question is one, find, we need to find one, the monopole moment. Monopole moment. 2, dipole moment. And 3, the approximate potential at large r. So, at far distance. So, now when we calculate the potential at large r, we will going to consider only the contribution of the monopole and dipole, because here you see that when we distribute the phi, so that was the contribution of the monopole, that was the contribution of the dipole and so on. Here for this system we just try to find out the potential at large r under the consideration that only the monopole and dipole contributions are there. Okay. So, first let us calculate the for case 1 the monopole moment. So, this is for case 1 and I tried to find out the monopole moment. So, monopole moment, in general monopole moment is nothing but the total charge. So, Q is the monopole moment and it defined like rho r prime dV. This is the way it defined. So, this is nothing but the total charge. So, very easily you can see that in all the cases the total charge, if you calculate, it should be 2q, here it should be 2q and here also it should be 2q, because plus 3q minus q, it should be 2q, and all the cases these values are same. But we will going to exploit this expression, because we know that for point charge how the rhos are how the charge density are defined for the point charge. So, that we will going to exploit here. So, the rho, that means the rho for the first case we know, because they are a distinct charge. So, minus q charge is sitting at the origin. So, minus q delta r prime, that will be the first term, and another term is plus 3q and it is sitting at a over the z axis at the distance a. So, I simply write delta function r prime minus a with z unit vector. So, that should be the location of this thing, and if you add these two, so that should be our the density charge density for the discrete charge. If you forget, so let me write it here once again. So, the charge density of the discrete charge was something like summation of q k, k 1 to say n number of charges are there, and delta r minus r k. That was the formula that we derived. So, that is the charge density for the discrete charge. I am just going to use this one, this summation sign, take care this plus. So, now simply my q is integration of rho r prime dv prime, and rho is this one. So, the it should be integration of minus q delta r prime dv prime plus 3q, I can take this 3q outside the integration, and then integration of delta r prime minus a z unit vector dv prime. But I integrate over entire volume. So, this quantity, both the cases, this quantity should be 1, and here if I take q outside, then this quantity will be 1. So, simply I have the same old thing, just q plus 3q, then it should be 2q. This is for case 1, and I believe for case 2 and case 3 you can calculate and find out what is the monopole moment. I am not going to do that, because this is just a repetition of the same thing. You just need to find out the delta function and you can do that. If you use the definition, the monopole definition this, okay. Otherwise, monopole is nothing but the total charge, you can easily calculate. So, the value should be 2q for all the cases. So, for case 2, the monopole moment again comes out to be 2q. I am not calculating that because calculation is exactly same, and for 3 q should be again 2q. But the interesting thing is to calculate the dipole moment, which is important, and then this kind of definition will be very much useful. So, now the problem 2, that calculation of the this is problem 2, where we calculate the dipole moment. So, dipole moment is simply integration r prime and then rho r prime and dV prime. This is the definition of the dipole moment over entire volume. So, in first case what happened? In first case, because I find out the rho in the first case. So, for case 1, because case 1 means for this distribution here, this is 1, for this distribution I should have my expression like this. So, it should be integration r prime and then rho I figure out. So, I just write this the value of the rho, it was minus q delta r prime plus 3 q delta r minus a z, the location of the charge. So, that value I put and then finally, I have dV prime. So, this quantity is my rho r prime. Okay. Now, I execute this part over entire volume. So, my P in this case is simply I can take minus q outside and integration of r prime delta r prime dV prime, and another integration is plus 3 q integration r prime delta r prime minus a z unit vector and dV prime over v. So, now you can see that this quantity should be 0 because I need to put r prime 0 as per the rule of the delta function. I am going to use this rule. If you forget, again let me write it here, integration function of x delta x minus a dx is equal to function of a very famous identity. So, that I am going to use here. So, the first term is simply minus q into 0 and second term is plus 3 q. In place of r I just simply put a z. So, it should be a z unit vector. So, my answer for case 1 is simply 3 q a z unit vector. That is the dipole moment I have for this distribution. Now, the distribution has changed and total charge is not equal to 0. So, as I mentioned, the value of the dipole moment is very much depends on the coordinate system. So, for this coordinate system I have one dipole moment, and this case even though the charge looks same, but the location is changed. So, obviously, the dipole moment should have some different value. So, let us find out the dipole moment for case 2. So, case 2. For case 2 again I am going to use the same notation, same formula, that r prime rho r prime dV prime. So, I need to find out rho r prime for this case. So, rho r prime for this case is simply, let us see what happened here. So, 3 q is sitting in the origin and minus 3 q is sitting in the minus direction, direction of z, and that means I simply have rho equal to 3 q delta r prime and minus q delta r prime plus a z unit vector. That is my rho, and if I put this rho here in this equation like before, I simply get my P to be 3q, because 3q is associated to the delta. So, 3q multiplied by integration of r prime delta r prime dv prime. So, this quantity simply gives me 0, and another term is minus q integration of r prime delta r prime plus a z dv prime. So, I can simply have here this quantity is 0. So, I have 3q multiplied by 0 plus this quantity is minus of q multiplied by minus of a z. So, that means for case 2 my the value of the dipole moment is simply a q z unit vector. So, previously the value was how much? 3 a q z unit vector, now it is a q z unit vector. Okay. Now, we are almost there. So, let us do the case condition for case 3. Case 3. For case 3, I have rho. So, let us first define the rho. Rho r prime for case 3 is, if I go back, so if I go back here, so this is a is sitting plus minus q sitting in the origin, and this is sitting over y axis. So, I simply have minus q delta r prime because it is sitting at origin, and 3q delta r minus a y unit vector. Okay. So, from here I can definitely I can simply write my result, and my result is minus q, it will be delta functions, it should be 0 contribution, and it should be plus of 3q and whatever the value I have here, that is a y unit vector. So, my final value is simply 3 a q y unit vector. So, this is the value of the dipole moment for case 3 the way. Now, the third part of the problem, that find out the approximate potential at large r. So, I can write my potential phi r as a contribution of phi monopole and phi not prime and phi dipole. This is for monopole and this is for dipole. I should not take all the higher order terms, other higher order terms, just so it is simply 1 by 4 pi epsilon 0 and then 1 by r then integration rho r prime dv prime. This is my monopole moment, which is total charge q, and plus 1 by 4 pi epsilon naught, and then I have p dot r unit vector r divided by r square. So, simply I can write this for case 1. For case 1, I know what is a monopole and I know what is q and what is p. So, I simply have the result. So, my result should be phi at r for case 1. It is, I can take 1 by 4 pi epsilon common, 4 pi epsilon 0 common, and the total charge was 2q divided by r and plus the monopole the dipole moment I calculated, and it was 3q 3qa, and then it should be r unit vector dot z divided by r square. Okay. So, that is the contribution I should have. Now, r dot z you can simply write r unit vector dot z you can simply write cos theta if the angle between these two is cos theta, then 1 divided by 4 pi epsilon 0 2 q divided by r plus 3 q a divided by r square, and then we have cos theta. That should be the value of the potential. Now, again I am not going to do the calculation for case 2, because in case 2 it will be similar, but you should be careful enough in calculating, because the dipole, the direction of the I mean you should be careful to find out this r. For example, let me write down the r here. How? So, the r unit vector is simply sin theta cos phi x plus sin theta sin phi y plus cos theta z. Why it is? Because you need to now consider the coordinate system, because the coordinate system is there actually. So, you can see that this value is x, this value is y, and this value is z. In this coordinate system, if I draw a r vector like this is my r vector, and the direction of the r unit vector is along this direction, and if I make a projection here, so this angle is my phi and this angle is my theta, right. So, this according to this coordinate system, this is my r. So, that is why when we have r dot z, I have a cos theta here, because z unit vector is associated with the cos theta. But for the case 3, let me write here for the case 3. For case 3, the potential that you calculate is 1 by 4 pi epsilon naught. Monopole contribution is simple, but the dipole contribution should be 3 q a that we figure out divided by r square, and then I should have r dot y, because it is along y direction, if you remember, for case 3. For case 3, if I check, it is along y direction, this one. Okay. So, now r dot y when you calculate, so it should not be cos theta, everything will be same. So, my result, so let me write down the result. So, 1 by 4 pi epsilon 0, and it should be 2 q r, and then plus 3 q a divided by r square, and this quantity should be sin theta sin phi. So, that should be roughly the potential. The next problem that I like to do quickly is this. So, problem 2, another important problem, problem 2. So, in problem 2, a spherical cell, I have a spherical cell let us put a coordinate system here. And it has a charge distribution sigma, but that is a function of theta, and that is sigma 0 cos theta. This is the way the charge is distributed. So, that means if I have a value r here over this sphere shell, then this is the angle theta. So, this r when the theta is 0, I should have the maximum value here, and that here we have all rho 0, that is the maximum value, and the charge is distributed like here. But when theta is pi, that is here, the value of the cos theta is -1. So, we have all the minus charge. So, that means the charge is distributed in this way, very unique kind of way. So, the positive charge, let us put the positive charge here, is distributed mostly here, and gradually it is reducing and no charge here over this axis, because when theta is 0, there is no charge over the axis. I should not put. So, this is a charge field region. On the other hand, the negative charge, let us put this color, is concentrated here, and gradually it is reducing and no negative charge. So, gradually it is reducing and no negative charge here. So, obviously, you can see there is a charge distribution here, because as the surface charge is distributed in this form. And the question is find out the dipole moment of this system. So, find out. So, first there are two parts of the question. So, the first question is find out the monopole moment. And second part is dipole moment. Dipole moment. So, how you calculate the monopole moment? The monopole moment is total charge simply, and that is rho r prime dv prime. That is my formula. So, here for this case I should not have this, because this is a cell, spherical cell. So, for this case my q should be integration of sigma, that should be function of some vector r prime and ds vector, right. That should be the not ds vector, it's simply ds, because this is not a vector quantity, ds over the surface integral. I just need to do the surface, need to make the surface integral. So, it is simple, because rho is given. So, rho is given as rho 0 cos theta, and my ds for spherical system is simply a square. If a, okay, I need to mention the radius of this sphere, and that is a. So, it is simply a square and then sin theta d theta d phi. Okay. So, now if I calculate my q, it should be simply sigma 0 integration theta goes to 0 to pi, integration phi goes to, because there is phi, so phi goes to 0 to 2 pi, and then I have cos theta, and then a square is there, so I should put a square outside, and then we have sin theta and d theta and d phi. So, I have 2 pi because d phi is there, sigma 0 a square out, and I need to integrate. So, another 2 I can have 2 multiplied by half, and then my integration over theta will be theta say 0 to pi, and this quantity cos and sin become sine of 2 theta d theta, right, and this is 4 pi sigma 0 a square, and the rest of the term is half, and if I do the integration is minus of cos of 2 theta and over 0 to pi, and we know that this integration is simply 0, right. So, so I have my total charge here 0, that means monopole moment is 0, okay, and it is expected because the way the charge is distributed by symmetry, you can see that there should not be any effective charge. Whatever is positive side, whatever is the upper side of the hemisphere, that is the lower side. Now, the next thing is important, that what should be the dipole moment. So, case 2, what should be the dipole moment? So, the dipole moment of this system, as per our notation, it should be written like this. Again, since it is a sphere, it should be simply sigma r vector and ds over the surface integral, and r now I need to write because it is a spherical coordinate system. So, r prime, or okay, simply I write r is over the sphere, it is a sin theta cos phi x unit vector plus sin theta, just before I did it sin theta sin phi y unit vector plus cos theta z unit vector, that is the value of the r. So, now I will just put this value of r and the sigma is already given. So, simply my p will be integration of a, the whole quantity, that is sin theta cos phi x unit vector plus sin theta sin phi y unit vector plus cos theta z unit vector, that is my r, and rho that is given sigma 0 cos theta, okay, and then ds again I calculate, and it is a square sin theta d theta and then d phi. So, this is the entire integration. I need to now integrate. So, let us take this a square outside, it become a cube because another a is sitting here. So, simply it become a cube and sigma 0, and now the integration has so different parts. So, let me do one by one. So, theta is equal to 0 to pi, and then I have phi equal to 0 to 2 pi, and then let me do one by one. So, it is sin square theta cos theta cos phi, and that is unit vector, and then plus I have sin square theta and then cos theta and sin phi, this is y unit vector, and plus cos square theta sin theta z unit vector and over d theta and d phi. So, this is a lengthy integration, but very much doable. So, I first I first need to calculate. Okay, let me do that. So, a cube sigma 0, and if I do the integration for theta first, theta is equal to 0 to pi, and let us take sin square theta cos theta out, and I do the integration for phi only. So, it should be cos phi and d phi and unit vector x plus say unit vector y. Let me write the unit vector first, then it is sin square theta cos theta integration 0 to 2 pi, and then I have sin phi d phi, and finally I have z unit vector cos square theta sin theta integration 0 to 2 pi and d phi. Okay, that is the total integration, and then over that I have d theta. Okay, so you can see that many terms will going to vanish here, because integration 0 to 2 pi sin phi d phi, that is integration 0 to 2 pi cos phi d phi, these two should vanish. Okay, then only remaining term is this. So, it is simply 2 pi a cube sigma 0 z direction integration of cos square theta and then sin theta, this is s sin theta d theta. Now, if you do the integration, you simply have, so I am not going to do the entire calculation, please do this integration, this is, so you will get a result which is 4 by 3 and then pi a cube sigma 0 along z direction. So, you can see that, so almost all the calculation I have done here. The problem is very interesting because we have a charge distribution here. It is not a single charge or multi charge, but this is a continuous distribution of the charge, and for this distribution of the charge you are asked to calculate the monopole moment, which is nothing but the total charge, and it is not easy to find the total charge. By symmetry, however, you can see that the total charge should be 0, but the important thing is to find out the dipole moment, and in order to find the dipole moment you need to use the formula or the definition of the dipole moment in this integral form, where the continuous charge distribution are here. So, little bit lengthy, but a very much doable calculation, and hope you can understand this calculation how to in today's class. Hope you understand how to calculate the dipole moment for discrete charge and continuous charge. I give two very important problem, and there are different kind of problem you can find in different books, and please practice that to find out the dipole moment and monopole moment for different charge distribution. So, thank you very much for your attention, and see you in the next class.